Hello and welcome to episode 26 of building a 2D game in Flutter, which has multiplayer support. At this point, it doesn't, it's just single player, but we are working on the server as we speak. So, in the previous episode, we mainly focused on packing, unpacking, and making the server work with the changes, and we were able to basically transmit player states, and we can see our game states with the player information. We finished the client, but if we would have not stopped the client, it would have run probably forever because that socket for communication stays open. So one thing I realized, well, first of all, let's make this an underscore because it's complaining. We're still complaining. Huh? Fine, we'll live with it. But one thing I was noticed that I said earlier that we won't need the applied thrust, right? Because it's a UI thing. But if an opponent player applied thrust, we would want to know because we want to animate that, right? We want to show, the little fire coming out of the back of the player. So then we need to look at a little bit, and I started looking while doing the break. How is a bool represented in this gRPC? It actually would just need, ideally it would be some sort of data type that has just one bit. Then it could be 0 or 1, right? True or false. So we're going to look at bool representation in proto buff, and we're going to see we're going to look here. I don't think that it's going to be so super efficient, and therefore we might actually do the extra step and show it in flags. So it's true and false, but what's the actual size of it? How much space does it actually take up in the message? So okay, so I'm still not sure. So it looks like it's going to be representative of some sort of integer, maybe. Doesn't matter. What we'll do is we'll have to implement the same thing that we did before. Basically, we're going to do something, a class called player flags, right? And so we say none equals 0, or I guess it's static const, right? And then the applied thrust is 0, 1. Then we're going to say bool contains a specific flag. We already have all this code somewhere, and we can say add a flag. And so since we already have it somewhere, we basically did this, I think earlier today even, when we did the game keys. So let's just refer to that code from there. So we have that. The thing is that if you look closely, I mentioned that if we end a flag with all the set flags, it basically comes out to be the key itself, but it's also true that in all other cases it comes out null, 0. So for instance, let's just say we were trying to figure out, so we have 0, 0, 0, and we have 0, 0, we have like this one set, right? So this is our flag, and we want to see if right is in there. So if right is in there, the result will be exactly that, like if we end it together, right? Which we're doing here. If it's not in there, so if like for instance this is 0, and this is one, maybe some other keys pressed, but right is not pressed, then actually if we end this all together, we get all zeros. It means we get 0. So basically what we can say, we can just say is not 0. And that's probably, that might be resulting in a few less instructions, because then we can look at the last, now I'm thinking of assembly actually, which I think it would probably optimize it that way. If it would look at the last instruction, if the 0 flag is set, that's probably much faster than checking for equality. So for that reason, we'll do it this way. And actually now we have to, well, we will check that in later as part of some cleanups. But basically now we're going to use the same code here. Let's say we're going to, what's going on? Okay, so let's copy this again. And basically it's the same thing, except instead of keys we have flags. So that's pretty much it. So and here we have it separate, right? But here we just have it together. That's either way works. So we just say we replace key with flag, and then our code is done. So except we're going to call this has, and that's pretty much it. And then here we have the flags. So now when we pack, we include in our packed player model, we include the flags. And that's basically going to be UN32. They will never be negative. We generate our code. No error. Okay, we learn to check for that. Now in the player model, we're going to basically say when we pack this, we say the flags equals player flags and then if we apply thrust, then we add this, add player flags dot apply thrust, right? And so now all we do is here we say flags equals flags. When we unpack, we're going to say so we get the flags here is basically the data dot flags, and then we're going to just say here flags dot has hold on a second. Oh, so basically we need to be able to pass this in. So we need to have a constructor that takes these flags as a parameter. So let's say list of flags. We're going to rename this to an public. It's fine, it's not a big deal. And the default value will be this. So rename this to that, and okay. And so basically then so flags dot add so because that's what we need to give it. So basically the pack is nothing else but that and accessing the flags here. And you could call it bits, right? Which is kind of maybe more understandable. So these are the flags, and then here we say flags.has, and we say player flags dot apply thrust. And so what we actually need to do, we need to create the player flags from this. Like that. Okay. So now, now this should work. So now basically what we'll do to test this, we'll run our little main file here, and we'll just see if this, if now the true is actually propagated. So it's true, right? The round trip, it survived. And now if we set it false, all right, cool. So we got that. Let's check that in as well. Adding player flags. So that's pretty cool. By the way, if you have any questions about what we're doing here and how this works and so on, feel free. That's why I'm not just recording this. I'm actually, doing this live so people can ask questions while we're doing it. Basically, now what we can do though is we can send press keys, and so far at this point they are in 32s, which is correct. And so here we have the game keys, and basically they are already packed, right? That's as packed as it can be, except obviously they have this extra value, this extra methods on it, which we don't transmit. But what I'm going to do is I'm going to do the same thing here. I'm going to rename this to bits, and then I'm going to create a constructor, the same thing I just did. Field we still need. Okay, so in that class we're going to use here. So also, I'm going to copy this over, and our spike will change it, and then we'll decide if we want to use it that way. So the game keys are a common thing, like the server and the client will access this. So and so what I'm going to do is I'm actually just going to move these down here. It doesn't have to be another class for this. Now what we can do in the client, we're unpacking the game state, we're communicating the client update, and so what are we pushing to the client update? We are pushing press keys. But the thing is, that's not really a good type to use. So what we'll use instead, we'll use something like a client update. I mean, what else could happen, right? That we need to transmit to the server than the inputs. I mean, there might be something like, the client wants to log off. Maybe there'll be chat messages, something like that. So what I'm going to do is I'm going to make a message. I'm going to create one, and let's say call it client inputs, or let's just call it, it's just a player, right? We're thinking of our clients as players, and so then we have press keys, and now we have player inputs, equals 1. Okay, so now we change the client update. We need to, so let's think about this before we generate. I kind of like this. This is client stuff, so let's move. Yeah, it's kind of hard to organize this. I wonder if we can import into here, but, and by the way, all this Java stuff, we never put this here and it still works. So I guess we don't really need this unless, these are probably just hints for other tools that we are not using. So now let's regenerate. Okay, it worked. Now in the client, obviously, we can no longer just do that. So when we have a press key, and we set space key, right? So what we actually want to do, we want to add game keys dot up. For now, we're gonna want to just apply thrust, and eventually we'll make it random or something like that. So basically, what we need to do is we need to create a player input. And so we only have one press key, right? We might have multiple. For now, we're just only going to have one. That's going to be fine. And so we create a clear input, and then we say press keys is basically this flag, right? And later on, we can allow multiple press keys and so on. So then the player inputs here is player inputs. Okay, so now that's fine. Now the server receiving that needs to actually look at the client update and needs to pull out the player inputs. And then it needs to say, so instead of increasing the angle, which we did here, we don't do this anymore now. We're going to say if player input. So we're going to, it almost sounds like we want to have a class here. I mean, for now, player inputs is pretty navigable, but at some point we might be want to pack player client updates as well. Well, for now, it's probably fine. So, but actually, you know what? As player inputs, right? These press keys, we probably want to convert them into game keys, right? Let's rename this to game keys because that's what we call it in the class. So we probably want to convert this to game keys, and then we can ask things. So we can actually do this for now, right in the client. We can say game keys equals game keys of player inputs dot press keys, and then we can basically say the player is this if the game keys dot has. We need to input this first. If game keys dot ha what? Has what? Oh, we said it contains, right? Okay, if game keys contains game keys dot why are you so complicated? So we probably need this. If it has up, then we'll basically say that the first of all the player applied thrust. And then the player, the velocity, we need to basically increase it, right? And so now we come to the point where we might actually need the player controller. So if we look at the player controller, we actually did a bunch of things when we did that. So I'm not going to try to pull in game player controller. We just basically do something very simple. But basically, if you look at the game here and the controllers, when there was game key up, we did all this stuff. We basically increased the velocity with the thrust force and all these things. We're not worried about this at this point. We just want to mainly make sure that we see a change, right? We're just testing things out. We're just spiking. So we're going to say velocity equals p dot velocity dot scale, right? We're just increasing it, let's say, by 1.2 on both ends, right? And so obviously that doesn't make sense if the player is rotated and so on, but we won't worry about this right now. So then we basically update this and we send it back. And now we got to go back to the client first because we still have an error there. It doesn't like something. We need to import game keys, and basically right now this looks fine. And what we'll need to do is we'll need to figure out how to randomly add different game keys so we can actually see, that this behaves differently depending on what the client does. So now we should actually be able. There's still some bug in there. Right. Okay. Now we should be able to launch the server, and we will also launch the client. And so now let's see. So we applied thrust through, obviously. And so since there's no game loop, right, we only get applied thrust through. And now since the velocity was 0, and we scale it, obviously we don't get any real increase there. So what we need to do actually is on the server, if p dot velocity is offset dot 0, we'll say that right. Or easier, we just, instead of scaling, we just say translate. So it's kind of like adding. So that should actually work. So let's launch the server as well. Client should have had, client couldn't connect. Obviously, clients need to be a little more patient. So let's see now. So now the offset is, the velocity is increasing because we keep applying thrust, right? Perfect. Now, obviously, we're only listening to events, but what we also should do is we should, like the server would have a game state, a game loop, where every so often it would actually say, well, if the the player has applied thrust once, already sent this model to all the other clients, and now basically the applied thrust needs to be set back to false. So we could probably simulate that here, but the thing is, right now we are basically, our loop is only active if we actually get client events, which is not ideal, right? We want to basically keep ticking, right? We need to tick, 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 tick. So maybe we can actually do that though. So maybe we can have a tick here. Where we can basically, so the stream that we're returning here, right, we need to be able to push more things into that. So we need to actually combine this. Yeah, we need to actually yield also from another function. So let's just say let's just try this real quick. Right, and all we're gonna do is going to yield gamestate.pack. So we're going to have to say that this needs to be an async star function. And so and so basically, we created a tick in the client, which we're going to use now. So we'll schedule a tick when we init our game service. Where do we actually init it? Oh, okay. So I guess then we can do that whenever we get created. Let's just create a constructor here. So we're gonna have a much faster game loop. Let's just say 50 for now. And then basically we want a tick. And this one we're going to put in a schedule tick function. All right, and so we schedule the tick in the very beginning once. And then every time we tick, we have to reschedule the next tick, right? So we schedule another tick. So now the thing is, what I wanted to see is if, well, no, we actually need to, yeah, so this is where basically Rx would probably come in use. So basically we need to combine streams here somehow. So basically the stream that we sent back here needs to be a combination of listening to these events and also of ticking on the game loop, right? So what we actually would want is we need a stream controller. Yeah, now we get it. So basically we need a stream controller, and instead of yielding here, we push onto the stream controller. We make this a totally different function, most likely, and then we'll basically, and we also push onto the stream controller here. So for now, we'll do it this way. Most likely, in the real thing, we will we'll pull in our X to control better what the streams are doing. No pun intended. As I'm typing stream controller, I'm saying that. But let's just say game state stream is a stream controller of game state. But it's a packed game state, right? And with our X, we could also just say, oh, well, we just send a normal game state, and then we'll map it. Actually, maybe that's what we'll do. We'll just do a game state, and then we'll map it. We can still do that anyways. So then basically here we return. So this one goes in a different function. Let's just say consume client events, right? And so what we'll do here, so we get the update events. We need to pass this in as a parameter, and then. So it needs to be async, but it's not going to be a generator anymore. What we'll do instead, we'll push this onto the stream. We push this onto the stream. So we push the game state on there. Okay. And so that's basically now a void function. So now when a client thing comes in, what we actually do is we are saying consume the client events, and at the same time we're returning the game state. So what we want to do right below here, we actually want to create a getter, which is going to be a stream of pack game state. So final, oh no, actually it's going to be get game state. It's going to return this one, but it's not going to be a pack game state. Sorry, it's going to be just yeah, it's going to be a pack because we're going to map it to that. And then basically what we'll do is take game state dot the stream actually. We'll map it. First we get the stream out, and then we map it to a pack game state. So we get, so what is it complaining about here? What we see. So we get a game state, and we basically will pack it. And then we say we want to be able to multiple clients to subscribe. And so why is it complaining? Maybe the get needs to be, and I can never remember the order of these things. Okay, so that's much better. So now basically we have a game state stream, a packed game state stream. And we should probably name it like this too. Packed game state, like that. And so now here we return the pack game state stream, right? And now basically the client will add events, plus every time we tick, we also add events, and we're ticking much faster than the client. So we should actually see multiple times this being returned to the client, and no thrust has been applied. So I'm actually quite excited if this works, because this was we did this much quicker than I had hoped. So let's clear this, and then let's restart. Okay, so all right, so now let's stop it and we can look at what we got. So we got a thrust true. We keep getting a thrust true. Oh, because we need to reset it to false, right? In here. So when we tick, we actually need to say that, and obviously there'll be multiple players, but this is fine for now. We're okay. Why? What's going on here? Game state dot. Why are you confusing me? Player dot applied thrust is false, right? Because it only will be true the very moment that the client sends us that this player applied thrust. Will send this. Well, this is a problem, right? Well, yes, we are setting it. So since we're adding it to the stream, and this is where things get a little hairy, right? Where maybe we want immutables, because I'm not sure what can happen here. Like we are saying, we're adding the game state, but maybe before it gets sent out, this code runs, and so the game state just got modified before. So actually, we need to have copy width in all the places, and we'll implement that in a second. So this means we can never. So what we'll do is, instead of having a copy width, we'll have a clone method. So anytime we'll send out the. Oh, you know what? You know what? The best way to do this is to actually pack it. Because when we pack it, we basically, it is like a clone and a conversion. So instead of doing the doing what we're doing here, let's just rename this back to game state, because now we're only going to have packed ones anyways. So what we're going to do is going to be a packed game state, and so we don't need to map this anymore. And then basically we're going to say add it and pack it immediately. So if you look through this code now, so the game state pack is going to pack the player. So the player, like the thrust, right, will be basically already converted to flags. So even then, if we then change that later, it doesn't matter, because you see all these values here are basically not used. We don't use a reference when we create the pack player model. We basically pack them all. And so even if we, and also we are assigning them to something, right? So even if we were to change player model at angle, well, we already pulled it off here and we passed it in here. So it's not a direct reference. And this is like a value type. And pretty much all the non-value types we basically are packing. So this is fine. So we don't need the clone in that case. This is not what we want here. There's a tick. Yeah, this is not what we want. On the tick, we also want to just basically we want to basically just add the gamestate.pack. All right, so now we have two places where we're adding to the stream. Probably you would want to make this a method so you can see where you're doing that easily. Right. What we also could do, we could make this actually a method. So let's do that. Send game state, and so we take a normal game state. So this is correct. So and then we basically say state.pack. Now, obviously, we could just use this the one that we have here, but I want to be a little more. Actually, but let's just use the field. Let's not try to hide that we have this global state, right? Okay. So now we can basically, wherever we're doing this, we can actually say send game state. Did we, what? Oh, we made it a public. We don't need to make it public. We don't want to make it a public. It needs to be private, and actually it needs to be, let's just put this somewhere here. So now we're going to, in here, we're going to send the game state, and also here, we're going to send the game state. Okay, so now we should be good. Let's restart the server. Tick async, what's wrong? Function model can't have return flag void. Yes. So we don't, so the tick is no longer doing anything and not returning anything. So it's perfectly fine. Let's clear this, and now let's see what happens. All right, so we have thrust false here for a little bit. So let's stop the client. So we should have, okay, so that's what I'm saying. We should have a thrust true once in a while. And the velocity doesn't change, and then whenever we get a thrust, the velocity changes. So this is actually pretty good. I mean, we're definitely sending back and forth. Definitely sending back, and oops, what happened here? Okay. Let's just run it again then. Server's still running, unless it isn't. Okay, so that's interesting. We need to basically, and those kind of things we can probably like figure out here the best. So basically when the client runs and then disconnects, the server somehow crashes. So let's just stop, and we can see that now the server is like, oh, I don't know how to do this. I don't know what to do when a client just decides to stop playing, but we'll have to teach it. But let's just look at what's going on here. So we're basically doing exactly what we have, a game loop now, and we can make it so if we want to have 60 frames per second, right? So a second has 60 frames per second. So that's like, I thought I read somewhere like 16 milliseconds per frame, something like that. We'll see. So yeah, so basically like a 60 seconds is like, a second is 1,000 milliseconds. If we want to have 60 frames of that, then we have 16.666. So we need to tick at 16 milliseconds, right? Roughly. And then we'll get 16. So, and then we'll have to see if our server can actually keep up with that. And that way the clients, well, the thing is so that 16 milliseconds, that's way ignoring latency. So we'll have way more latency. And so in order to show for 16 frames per second, 60 frames per second, we know that we're going to have to do some extrapolation, interpolation on the client, and we'll talk about that once that becomes actually, once we get there. For now, basically, all we want to do is we'll have the server dictate everything. We'll have the server run everything. The client will just tell it what's going on, and later on we'll worry about latency. But we have what we wanted. So now, for now, so basically, we're going to check this in. Handling client up key plus sending regular game state updates. Okay, so we don't want to push. So one thing I wanted to try. So first of all, yes, it's not cool that the server crashes when a client disconnects, but let's just do multiple clients. And obviously that's going to be a problem because we only have one player. But if I do dart lib and I say client, we should also get updates here. Okay. Interesting. So we have a bunch of errors. Somehow we can only connect one client. Oh, see, that's what I'm talking about. So the stream has already been listened to. Okay, but it said it's a broadcast stream, so why does this not work? Didn't I say as progress? Yes. I don't understand. I do not understand why this is suddenly a problem. That's the only place where we use it too, I think. And that's where RX comes in healthy, because this is not an issue at all. If you want the multi-subscription stream that produces the same events as this, the original will subscribe to the stream. I don't understand why this is complaining, unless we didn't restart the server. We did in the meantime. I do not understand at all. I can rewrap it. That's not going to help anything. I have no idea why this is happening. So we'll solve that later. Yeah, I have no idea why that's happening. But one thing that we want to do is, so let's forget about this for now. We'll use RX. There's not enough time. We have about 10 minutes left. There's not enough time to actually pull our X in right now. We do that later. But what I wanted to see is like if once the client is connected, the server crashed. So actually what I'm going to do instead, I'm going to launch the server in debug mode. And I'm going to tell it to break on dot exceptions. Okay, so that's good. So now the server is listening in debug mode over here. And now we're going to launch the client for a little bit, and then we'll stop it. And now I want to see why it, okay, so here it's crashing in consume client events. So okay, so we need to maybe figure out so it's crashing. I think it's crashing because the stream is closed or something, right? So maybe we have to say so I guess the examples were very simplified. So basically, yeah, we probably won't use a for loop like this then. But what we could do for now, which dot Is there a way to figure out if it's closed? It's empty. Is there a way? So what is this? A stream, right? Dart stream. And the streams work pretty well in Dart, but they're not quite as fully featured as our X streams, and they're fully compatible though, so we can easily switch to our X streams. Dart stream detect if closed. Well, okay, we can listen to undone or something. Okay, let's try that. Basically, if the stream is done, we'll just break out of this loop. If update events dot is done. Okay, so update events dot on. Okay, well, we'll do it differently. We'll just create a subscription. Final sub is update events dot listen. And so we'll give it so we have data coming in. Call it CU, so let's keep it in CU. Don't need this. And then we just need okay, so that's that. Okay, yeah, I keep messing this up because TypeScript and Dart, as I mentioned, are very close together, but they are not quite. So then there's an on error and an on done. So what I basically can see, the on done, I don't know if this is clean or not, but we're basically going to say sub dot close or sub dot cancel. But the thing is, even like this way, since this is a sub, we are just listening, we are like passive now. That also means that we're not trying to pull something, like the for loop await was trying to keep getting values out of the stream. And so I think if we have it this way, we are probably going to be okay. So what's the problem here? It can't be referenced before it's declared. But it is declared. And it is a closure. So what we're going to have to do is declare it first. Sub equals, now it's happening. Okay. I think that might work. It's not a 100% clean solution, but it's definitely better than crashing. So let's try this. And if you fix it, then we can say, okay, this is good enough for today. We accomplished a lot today. So now let's close the client. Why? Let's see if we handle an error. Let's see what happens here. So we have an error. Print, right? Let's see if that at least keeps us from crashing. So we launch the client again, and then we stop it. And it prints the error, but the server is still listening. And now we get this thing. But the server was still up, right? The server was still up. We're gonna figure this this whole stream has already been listened to error out once we switch to X. It will just go away by itself. I'm not entirely sure why. Since I'm using this as a broadcast stream, I'm not entirely sure why it's complaining. Quite honestly, I have no idea why that is going on. Right here basically saying return this, right? I mean, just for fun, we're gonna do another. We're gonna rewrap this. So every time, so maybe we'll do that. So every time a new client comes in, we'll send it a new wrapped broadcast stream. So maybe that'll actually fix it for now. So let's do this. Let's launch one client. It's running, and let's launch another one here. We got another error this time. Whoa, what happened here? Okay, now that's yeah, whatever. We'll give up. Right? We even gave it a different stream. I have no idea why this is happening. But for now, we are good. We have a running server, a running client, and basically what we did, we made sure that the server doesn't crash when the client disconnects. Instead, it prints an error. I'm not even sure why this has to be an error, but maybe that's what it's considered. Like when the client connects suddenly, the server decides that this is an error. So for now, we're going to check this in, and we say server handles disconnect client connect error. Disconnect error. Okay, so that's fine. This will be the end of this episode, and actually also for today. We will continue tomorrow, 9 p.m. Eastern. As always, what we will do in the next episode is basically we'll pull in our X, we'll make this a little better. Once we have this working with our X, we basically want to iron out all the kinks, right? We want to make sure that we understand, in this little example here, we understand why things are going wrong when they go wrong. Once we have all that figured out, we will actually go back to our main game and start pulling things in there. And basically then, because I don't want to even go as far as pulling in controllers here, right? We'll just make sure that we handle different game keys. We'll randomize those a little bit. And once we have all that working and it doesn't cause any errors or issues anymore, then we'll start going back to the main game and pull the server in there and start making everything multiplayer. So that's going to be awesome. And thank you very much for watching. I hope you keep watching if you're watching the playlist on YouTube. And everyone on Twitch, I hope you're coming back tomorrow. Thank you very much. Bye.